Hi guys, today we are discussing about our major project. The title goes Cyber Fraud Detection on Credit Card Transactions, and we are under the internship through placement. And our group mates are Vamsi Krishna and Anirudh, myself Jashwant. Okay, next slide, bro.
So
Our
our
industry name
industry name is OpenText Corporation. So the duration of the internship from Jan 12th to June 12th. So our duration is of 6 months. And our industry guide is Sandeep Kumar, and he is an hiring manager.
And these are our agenda in which we gonna discuss in this video. And starting from the extract and ending to the journal publication, which we have not completed yet, but we gonna complete that. And coming to the extract, in the recent times, credit card fraud reduction is the most demanding and most frequent in nowadays. And we are using currently we are using credit card to buy online and as a mobile wallet for a simple payment to a merchant, has become daily action for most cardholders. And this credit card fraud detection is by foremost the frequently happening issue within the display world. And as a result of flow of millions, online transactions is subject to various types of fraud. And traditional techniques for detecting fraud detection, sophisticated fraudulent techniques to be limited in a to analysis of the cardholder's behavior, or to a static rules of risk management of frauds. To distinguish the false access, the credit card fraud detection location framework was presented here in this PPT. The next.
And the objectives of our project is where the implementation machine learning algorithms to detect the credit card fraud detection. It helps to identify suspicious events and report them to analyst while letting normal transaction be automatically proceeded. And we will be showing the whole thing after the presentation of our project. In the demo, you will be seeing everything. Goes to Anirudh.
Next slide, please. So the main scope of the project is, so we couldn't reach the 100% accuracy. So while detecting, we couldn't reach the 100% accuracy of the fraud detection. So we didn't create any system that gives an 100% and accurate accuracy. So for that any such process, there are some the room for improvement. So this model can be further improved with the addition of more algorithms into it. So while taking up different algorithms which suits this project, so we took up some of the algorithms that is going to be implemented in this project to get at least an accurate accuracy and rather than the 100% accuracy. So this provides a great degree of modularity.
So coming to the introduction part, credit card fraud is growing concern in the present world with the growing fraud detection in government office, corporate industries, finance industries, and many other more. And for this kind of thing, we have came with a solution through machine learning. However, machine learning techniques have been able to meet this need. And in the current scenario, in this PPT, we are going to present a comparative study of machine learning techniques which gave the best results according to our plan. But we applied some of the set of the data which was gathered to the Kaggle. The object of the study is choose to the best credit card fraud detection techniques to implement in the future. So coming to the literature review will be explained by Jashwant.
And our literature review, we have attached some nearly 6 literature reviews, and the other papers were attached at the last, like some 8 to 10 papers were attached. And the literature review goes like from the L. Bauchi and the Kuldeep Randwa. The third one is Lakshmi SVSS. The author proposed that in recent years for banks has become very difficult for detecting a fraud in credit card. So such way SP Maniraj. And the fifth and sixth literature reviews are goes like Vamsi, next slide, please. Umisirat, Ethel, and Sai Kiran. Sai Kiran described that like Naivbase improved k-nearest algorithm, they have used a dataset on which they had applied the algorithms to identify the fraud transactions. By the dataset taken from Kaggle, they are tracing the performance of benchmark and real-world datasets. In addition to the boost and majority voting methods are applied for forming the hybrid models.
So
Anirudh, next slide.
I'm going to explain about the design and methodologies. So for this implementing the project, so we have categorized the project into 4 modules. That is, the first one is data collection and training the machine learning algorithms. The second one is processing the data, and the third one is applying the input, and fourth one is the get the output. Next slide, please. Yeah, so first one is the data collection and training using machine learning. So as you can see the below diagram, so this diagram consists of different types of data sets that we have taken. So it's a previous data sets of the transactions. So normal transaction or any fraud detection for fraud transactions. So we have collected in one grid, and we have collected the data. So next step is the processing of the data. So using we have used some of the algorithms like k-means algorithm. So with the help of that, so we have done the process of the data. So processing the data, which means taking the data sets and converting and getting the output from that. So next is the machine learning algorithm. Using some of the main algorithm terms. So we have been applying the process. So after that, we'll be applying these machine learning algorithms. Next slide, please. So after processing the data and using the machine algorithms, so we'll be getting an output in the form of graphical representation. As you can see, there's a confusion matrix of decision tree. So where we got the output from the given data set. Next, standards and policies auto Vamsi.
And basically, these are the standards and policies we have acquired from the internet for our verification for our project. Basically, we have basically these are the IEEE papers we have searched from the internet. First one is IEEE 829, and second one is IEEE 830, IEEE 1012, and IEEE 1016. And these are the IEEE papers which have suited for our project. And next we'll be going to Jashwant.
Yeah, here we go. The implementations. In the implementation, to the better understanding, we have included the architecture diagram, data flow diagram, use case diagram, and the class diagram, activity diagram, sequence diagram, collaboration diagram, if it's applicable. As collaboration diagram isn't very mandatory, so here we go. The architecture diagram. By taking read the data set over the sampling is done, we will get into some feature selection. AdaptBooster is our algorithm we have used here, prediction of outcome for test data. Then we are including the test sample data collected from the Kaggle dataset. So finally, performance and accuracy result will be given. So the next diagram is data flow diagram. In the data flow diagram, it shows you how the data is flowing and the exact representation of the project, how data is working on it. As we begin, we select some algorithms. After the algorithm selection, software implementation of algorithm, testing the algorithm, and then compare the test results with known values. If the result is okay, we'll go to publish test results and end. If it isn't okay, then refine the algorithm. We'll change the algorithm to the again algorithm selection. We'll go till the which algorithm is giving the accurate results. So the next diagram. Is use case diagram. In use case diagram, as here the user is the credit card user and goes like report fraud, check transactions, update settings. In the check transactions, fraud detector using machine learning. And the next one. Class diagram. As all we know, in the class diagram there are some classes, and the classes are like connected like the branches to the other classes. First, the credit card and the transaction and the fraud detector are the 3 classes. In the credit card, the findmost are card number, expiry date, CVV of the mandatory for the credit card details, and the transaction details are transaction ID, card number, amount, and date when the transaction is done. In the fraud detector model and threshold. So here goes to the ML model we are using and the predictor. I mean, predictor is the accuracy predictor. The next diagram. Is the activity diagram. In the activity diagram, classification, credit card frauds and committed methods, then identifying issues and challenges. After analyzing of data set, after issuing after identifying the challenges, then go to adaptive machine learning techniques. Here we mention adaptive because only certain machine learning algorithms will help and sort out the problem. Then evaluation the metrics, comparative study, and these outcomes. We have mostly used supervised learning. Unsupervised learning is the only certain algorithms. And the next algorithm is a sequence diagram. Here we can see that in a sequence, first credit card transaction of data set, division and dependent features, extracting the important features, create training and test data set, fitting to classification methods. Here the adapt boost and gradient boosting we have mentioned particularly after analyzing of accuracy, precision, recall and F-score. These all will be demonstrated in the demo while we are running the whole project. Then predicting the fraud transactions. Like in sequence diagram, we have mentioned particularly you can see predicting the fraud transaction. The collaboration diagram goes like credit card transaction, credit card detection of techniques, decision making, fraudulent transaction. Here raise alarm in the sense like it will show these at certain period we have more fraud transactions. The next diagram. And the year diagram is the entity relationship diagram. Here we have entity related to the every entity in the project, like from the incoming transaction to the outgoing transaction, and the time, date, everything is like related to each entity. Every class is an entity in the year diagram. Yeah.
So basically, coming to the testing department, we have done several testings like unit testing, integration testing, functional testing, white box testing, and black box testing. So basically, coming to the unit testing, everybody knows that unit testing will be connecting on small parts named as units also, which we are going to connecting on small transactions. Like unit testing is a testing level software which individual units components of the software are tested. The purpose is to validate that each unit of the software performs as designed. It usually has only few inputs and usually has a single output. So this is the testing picture we have taken a screenshot from our code, and you can see this. And basically coming to the integration testing, it is a integration testing is a level software testing where individual units are combined and tested as groups. Means in the unit that individual units means the units which are tested in the unit testing are combined in the integration testing, and they are considered as an individual units, and they are tested as a group here. And the purpose of this level of testing is to expose the faults in the interaction between integrated units. Test drivers and test subs are used to assist the integration testing. And in integration testing, credit card fraud detection using machine learning involves the testing of integration different components of the system to ensure that they work together correctly and efficiently to detect fraudulent transactions. And coming to the functional testing, basically the functional testing is used to detect the functionality of our code and how it's able to function during the runtime. And functional testing for credit card detection using machine learning should ensure that system is actually detecting fraudulent transaction and efficiently processing large volumes of data in real time and while maintaining data security and privacy. And next, coming to the white box testing, white box testing is a software testing method that involves examining the internal workings of the software to ensure that it functions correctly. In the context of fraud detection on credit card transaction, white box testing can be used to ensure that the algorithms and model used to detect fraudulent activity and functioning as indeed. And coming to the black box testing, it is a software testing that focuses on functional requirements of a system without examining its internal workings. It in the context of fraud detection on credit card transaction, black box testing involves testing the system from the perspective of an external user without examining the underlying algorithm or data structures used to detect fraudulent activity. It mainly considers the external factors, and these are the test results. The basically we can see that we have taken 28. We have taken the total number of transactions, and normal transactions are 20 this, and the fraudulent transactions are 492. Then the percentage of the fraud transactions is 0.17. And basically this is the input we have taken from this is a kind of a data set, and these are the outputs we have taken, mainly XGBoost, decision tree, logistic regression, KNN, and these are the outputs of the different algorithms we have used in our code, and demo video link. And coming to the conclusion, will be explained by Ankit.
Conclusion goes to Anirudh.
Yeah. So conclusion. So as credit card fraud becomes a serious concern in the world, so this brings to a financial loss to the world and to all the people. So use of credit, and like as credit goes everywhere, but the transaction for fraud transactions goes everywhere. So the prime goal of the project is to define some of the algorithms that confer the appropriate. So it can be adapted by credit card companies for identifying fraudulent transactions more accurately. In less time and cost, different machine learning algorithms are compared, including logistic regressions, decision tree, random forest, artificial neural networks, KNN. So by using these algorithms, so which scenario the best fit for the scenario? Yeah. So
Yeah,
the
future
future
and
enhancements. So in the future, so we'll be starting to attempt and explore more credit card fraud detection using real-time data. So as the technology grows, so major algorithms is also grown, and different methods can be implemented. So for the credit card fraud detection. So since the Adam booster classifier shown better results, so this comparison with other types of classifier, such as gradient boost, so based maybe contribute further to the body of the knowledge. So next slide. So these are some of the web reference and web links shown in the PPT. Next slide, please. Yeah, so as you can see, these are some of the reference as per the IEEE. So as per Jeshwan said, there are some of the references which have been attached below. So they are almost like 4 to 5. As you can see here, SP Manaraj, Aditya Saini, Lakshmi SVSS, Andrea Dahl. So can you next slide, please? Yeah, Kuldeep, Suresh K, AL Bochiti, and Pamshriti A. And so these are some of the reference we have taken as per the IEEE. So my friend Vamsi, so this is the plagiarism report which is attached in the below of the PPT. And now my friend Vamsi will be demonstrating the code.
And these are our offer letters which are given by the company, and this is our poster presentation which we have explained everything about our methodology, introduction, and our results, and we have what are the standards and policies we have used, and we have gave complaint conclusion, and we have mentioned our details, everything, our mail IDs and phone numbers are and our guide which also has to do this project, and we can contact her anytime you want. Next, I am going to demonstrate the project. Uh, Coming to the project, basically we have taken this is our code which will be going to run in the Google Colab, and next I'm going to show the CSV file. This is the CSV file which I have uploaded in the Google Drive. This is the data set which are all the transactions are stored in this, and coming
the
to
data
the
set
next
is from the Kaggle.
And next, coming to the code which we are going to run, which are going to run in the Google Colab. Basically, we are going to run this from the starting, and it's going to ask our permission from the Google Drive, and it is running. You can see basically this is our project, and basically it's going to run. You can see that's running. After that, it's going to give us the output in the form of confusion matrix, which we are going to detect the fraudulent transactions and the normal transactions in the graphs. It will take some time because due to the internet activity.
And in the code initial stages, we have only given the sample input from the Kaggle, and the input is thoroughly checked and accuracy is given, and then the remaining 70% or 75% of the whole input will dataset will be inserted as input, and then accuracy will be given in the graph. Right, Vamsi?
Yes, yeah. Basically, we have stopped. Our project is mainly to detect only the FN score, but our college professors have suggested us to come with a confusion matrix, which will be showing in the form of graph, so they can so they can see the statistical things. So it's been running.
Yeah.
So basically, it's running the SVM. So don't bother, it's going to take time.
So as per the reference, so the algorithms that we have used in this project are logistic regression, decision tree, random forest, artificial neural network, and support vector machine, as is said below. So, like first, the logistic regression is so this statistical method. So this is used to analyze a data set with one or more independent variables, so that determines the outcome of the dependent variable. So the next one is decision tree. So this algorithm is a non-parametric supervised learning, so which is used for the classification task. So decision trees are used to build a model that predicts the outcome based on the set of rules. So the next one is the random forest. So this algorithm is a sensible learning method that combines the multiple decision trees to improve the accuracy. So the fourth one is artificial neural networks. So this machine learning model is inspired by the structure and function of the human brains. So artificial neural networks can be used to create a model that learns from the data and predicts the probability of a transaction being fraudulent based on the set of features. And the fifth one is the support vector machine, that is SVM. So this algorithm is a supervised learning. So it is used to classify the data into one or two subclasses. So it can be used to create that predicts the probability of transaction being fraudulent based on the features. So it's important to note the selection of algorithms. So maybe depending upon the size of the problem at the hands of SVM work by finding the hyperplane that separates the two or more subclasses of the data. So as the data is acquiring from like data set is acquiring, so it takes time to run all the codes.
As the code will be analyzing whole algorithms and the data, it will take much time, but the accuracy will be like around some 89 to 95, and we are working on getting the more accurate results. By that we can detect the fraud soon or later.
So basically, project has finished, and this is the implementation. So you can see these are the output images which have been,
That is statistical data collected from the after the accurate results.
and these are the details of every algorithm which has been implemented from the code, and they are taken from the data. And finally, this is a project.
Thank you everyone. So this is our whole project. We have working on the accuracy of the fraudulent detections and transactions. Once we are done, and the though we it has more to work on future, this will be getting more and more applause, as the when we have detected the whole credit card fraud or whatever the debit card fraud transactions, the when we find the or analyze the whole transaction frauds, we can prevent and stop the like fraud transactions present or future. Thank you. Thanks everyone.
Thank
So
you.
thank you.